Hello and welcome to this Dr. Ross Maths video on rotation. Now rotation is one of the four types of transformation. We've got rotations, reflections, enlargement and translations. And rotations, as you've seen the word before, just means something's rotating, spinning about a particular point. So this shape here, A, if I spin it about this particular point, it ends on the right side of my finger, which you can see B indeed was. B was originally on the right side of my finger. So you can see that A is spinning around to get to B. Now, you get 3 marks for describing a rotation. So if we just do A first, the transformation from A to B, we get a mark for identifying the type of transformation, so it's a rotation. We also get a mark for saying the angle which it's rotating. We can see that A is doing a half spin around this particular point here. So it's 180 degrees. It's a rotation 180 degrees. And then we also need to give the center rotation. Now I've already said it's spinning around this particular point. So shape A is spinning around 180 degrees to get over here. So we can see it's the 0.35. Now how would we identify that without being able to visually see it like that? And the way we do it is that if it's a 180 degree spin, let's take 2 equivalent points. So can we see that that point is equivalent to that point on this shape? And what you do is you just join them together. So if you join these together, and then what you do is you just take the halfway point. So we can see the middle of those 2 points is that, and that gives you the center of rotation. Now this method only works if it's 180 degrees rotation. So we just write about the point, and then we give the coordinate, which is 3, 5. What about part B? So now it's from A to C, so A to C. Now this time, we can sort of see that that shape is kind of rotating like that because it's originally upright and now it's horizontal. So that's a 90 degrees clockwise rotation. So if it's not a spin of 180 degrees, you have to say whether it's clockwise or anti-clockwise. For 180 degrees, it doesn't matter because whether you do 180 clockwise or 180 degrees anti-clockwise, it doesn't make a difference. So for this one, A to C, we've got a rotation 90 degrees clockwise and then about the point. And now this is where it gets hard. Now to identify the center rotation for a 90 degree rotation, first you have to have a sort of sense of like roughly where the point is. So if I say put my finger here as the center rotation and I was to sort of spin A, rotate A around that point, we can see it's kind of getting to the right kind of area, yeah? So we can see that the center of rotation is going to be sort of this kind of area. But let's just try specific points. So if we were to try here, as the center rotation. Now let's pick a point on the shape A, the pointy bit, and the equivalent point on C. And then what I do is I draw some lines towards this center of rotation, this proposed center of rotation. Now can you see that that's not 90 degrees? That looks a bit more than 90 degrees. The other way you can tell is that the counts across and the counts up and down, they should swap round. So can we see, to get from here, the center of rotation to this point is 1 across and 3 up. But this is 4 across and 2 down. And they don't correspond to each other. So that's not the right point. What about the origin? Now if we do the same thing, so we do a line to here, a line to here. I know it's getting a bit messy. Now that looks like 90 degrees, but if we check the counts, we can see it's actually right. This is 1 across and 4 up to get to that point from the center of rotation. So 1 across, 4 up, and this is 4 across, 1 down. Now we can see the 4 and the 1 swapped. So the 1 across for this point became 1 down. So left right becomes up down, and up down becomes left right. So the 4 up became 4 across. So we can see they swapped. So that is the correct center of rotation. So we can put about the point 0, 0, or we could write about the origin. What about C? So from A to D. Now A to D, we can see again it's kind of a 180 degree half spin like that. So it's a rotation 180 degrees. We don't need to write anti-clockwise or clockwise. And then we saw that for 180 degrees before, we could just find 2 equivalent points and find the midpoint. So if we pick this point on A, and we pick the equivalent point on D, which is here, and we join those together with a ruler, the midpoint of these 2 points is exactly here. So that's the center rotation, which is -2, 3. So it's about the point minus 2, 3. And then finally D, we want from A to E. So if we look here, A to E, that seems to be 90 degrees again, because it was sort of upright and now it's horizontal. So, and you can also see, because the right angle's here, it's rotating anti-clockwise to get here, because the right angle is then in the right place. So it's a rotation 90 degrees anti-clockwise. And again, this is the hard part, to find the centre of rotation. So if we just give a vague guess to start with, if you sort of put your finger here, can you see that that shape is sort of rotating about here? But if we were to try that as a point, and then use these equivalent points, so here and here on A and E, because that's the sort of the pointy bit and that's the pointy bit, can you see that doesn't work? If I join it to here, that's 3 up and 2 across, that's just 3 across, so that doesn't work at all. What about this point here though? And apologies for this being a bit of a mess. Now, from here to here, that's 1 across and 2 up. And from here to here, the centre of rotation to the equivalent point, that's 2 across and 1 down. Now, it looks like 90 degrees, and indeed, the counts work, because the 2 up to get to this point became 2 across to get to this point, and the 1 across to get to this point became 1 down to get to this point. So the counts have swapped correctly, and it just looks like 90 degrees, so that indeed is the centre of rotation. So that was 2, 2.